Hello and welcome to the March 2023 Longevity Review, presented to you by the Canadian Longevity Association, a federally incorporated nonprofit whose mission is to help accelerate the introduction of effective longevity treatments and to ensure their free availability to all Canadians under the healthcare system. My name is Chris Linnell, and I am the founder and president of the association. We are a volunteer-run organization and are always looking for more help. So if you would like to assist us in our mission, then please get in touch via the links below this video. In this month's review, we're going to look at how changes to lifestyle can reduce your epigenetic age, the benefits of a healthy diet, as well as the benefits of exercise, though you might not need to do as much as you might otherwise think. Also, we'll be looking at a study which showed a combination of two supplements can reduce cardiovascular mortality. And also, perhaps we don't need to exercise at all, according to a study in mice using gene therapy. So let's get stuck in. Oh, and at the end, I will reveal the results of my 3-month rapamycin trial. So anyway, let's get stuck in. So in this first study, an 8-week dietary and lifestyle intervention resulted in a 4.6-year reduction in epigenetic age. Now, the study was incredibly small. It only involved 6 women. However, it was a follow-on study from a study which came out in 2021 involving 43 men, which also showed a reduction in epigenetic age, though only 2 years, I believe. So this was kind of corroborating that first study. Let's take a look at the study itself and what that intervention involved. So as I say, only 8 weeks, only 6 people, but as I say, it resulted in let's make this a bit bigger so you can see it, a 4.6-year reduction in their epigenetic age, according to the Horvath DNA age clock, which was a first-generation clock, the first proper epigenetic clock, which came out in 2013. There are subsequent clocks, but maybe better clocks, but they chose to go with this first one because I guess that previous study used that. Anyway, let's take a look at, well, first let's take a look here. You can see the reductions in average age according to 2 different mathematical methods. I'm not a mathematician, so what t-test mean difference or Wilcoxon sign rank test of median differences. No idea actually what that means. But let's take a look at what the intervention involved. And it should be something that it could be achievable for most people. So, well, maybe the first one could be a stumbling block because it involved 3 servings of liver of 3 ounces each per week, preferably organic, though I believe they also gave capsules for those who did not like the taste of liver. 5 to 10 eggs per week, ideally free range, organic, omega-3 enriched. And then every day, they had to have 2 cups of dark leafy greens. So that could be things like kale, Swiss chard, collards, spinach, etc. 2 cups of cruciferous vegetables like broccoli and cabbage. 3 additional cups of colorful vegetables of the participants' choosing. So I guess like red peppers and tomatoes and things like that. I guess tomatoes aren't an actual vegetable, but there you go. 1 to 2 medium beets, 4 tablespoons of pumpkin seeds, 4 tablespoons of sunflower seeds, an extra serving of a methylation adaptogen. So that could be anything from half a cup of berries, some turmeric, rosemary, a couple cloves of garlic, or just some green tea indeed. Also, as part of the diet was 6 ounces of animal protein, though they say grass-fed, pastured organic, and all that good stuff, and 2 servings of low glycemic fruit. So that would include berries as well. Obviously, glycemic, that means how fruit that doesn't affect your or doesn't cause massive glucose spikes. And the idea was also to stay hydrated, to have, I think, up to like 8 glasses of water a day. A mild form of intermittent fasting, so not eating between 7 p.m. and 7 a.m., or at least 12 hours fasting after the final meal of the day, including healthy oils, so not saturated fats, but I guess mono or polyunsaturated fats like coconut, olive, flaxseed, pumpkin seed oil, as it says there. Avoiding things such as sugars and candy, dairies, grains, and legumes and beans. It was slightly surprising there because I would consider legumes to be quite healthy, and minimizing plastic food containers. And in addition, they were also given a couple supplements. One was just a mixture of 2 servings of a Phytoganics, I guess belonging to some supplement company, giving additional phytogens and stuff, and also a probiotic consisting of Lactobacillus plantarum 299V. So again, for maintenance of the gut. And apart from diet, this intervention also involved exercise, so 30 minutes, minimum of 30 minutes exercise at least 5 days per week, at 60 to 80% maximum exertion. Try to get at least 7 hours of sleep a night, and also they were given a relaxation program. So, I mean, as you can see, this intervention was quite comprehensive, involving, very specific dietary recommendations and exercise recommendations. But, resulted in, for at least for 5 out of the 6 women, it resulted in a reduction in their epigenetic age. And let's make this a bit smaller and go up. So here you can see the 6 participants, and apart from one who had no change over the 8 weeks, all of them had a reduction in their epigenetic age. I mean, this doesn't mean they actually got younger, but at least according to this one measure, their age reversed, or they certainly probably got healthier as a result of this intervention. Again, I would just repeat the caveat again that only involved 6 women, but previous study in 43 men showed similar results. So certainly none of these recommendations are bad for you. Following on from that first study are 3 dietary studies showing the benefits of a good diet, specifically a Mediterranean one for the first 2 studies. Let's just take a brief look at these. So the first one involved 60,000 participants from the UK Biobank, so slightly larger study than the last one, and a 9-year follow-up. And here they were looking at dementia risk, and basically they found that there was a 23% reduction, measured here is a 0.77, hazard risk. Anyway, a 23% reduction in dementia risk for those who most closely followed a Mediterranean diet. The next one, an even larger study, this time looking at cardiovascular disease and death risk. And basically, this involved a sort of an umbrella review of 16 studies involving 700,000 women over 12 and a half years, which resulted in a 25% reduction in cardiovascular disease and overall mortality, overall death risk for those who followed a Mediterranean diet most closely. Now, in case you're wondering what a Mediterranean diet is, as it says here, the Mediterranean diet is rich in whole grains, Vegetables, fruit, legumes, so beans, nuts, and extra virgin olive oil, moderate in fish and shellfish, low to moderate in wine, low in red and processed meats, dairy products, animal fats, and processed foods. So very similar to that previous lifestyle intervention, though they do include legumes or beans in it. And finally, the last of these three studies, it wasn't specifically looking at Mediterranean diet, but various healthful diets, and basically they found out that people who followed various diets. Actually, I'll open the other link. So the various diets like I should go back to this one. So the various diets, such as, again, the Mediterranean diet, but various sort of, I think, the DASH diet for hypertension, and but to be fair, most of these diets are fairly similar when it comes down to it. But here they found that people who followed, so this involved three different studies in total, involving a total of 200,000 people, both men and women, and there was a 20 to 42% reduction in chronic disease risk. So we're talking about cancers or cardiovascular diseases or type 2 diabetes. But basically, people who stuck most closely to it showed greater benefit. And here there was, unfortunately, the full text is behind a paywall. But here, this chart, you can take a look and see all the different foods on the right-hand side, and if they here's whether or not they were beneficial or detrimental towards chronic disease risk, with blue being beneficial and red being detrimental. And you can see at the bottom here, maybe make this a bit bigger. So things like high energy drinks, French fries, red meat, processed meats, all caused worsening or greater risk of chronic disease. And at the bottom here, you can see the various different diets that were tested. And then things that showed an improvement, again, cruciferous vegetables like broccoli, fish and seafoods, other vegetables, legumes, leafy green vegetables, dark yellow vegetables, fruit, coffee, whole grain. It's like wine was beneficial here. Unfortunately, beer wasn't, apart from maybe one diet. And yes, liquor was definitely not beneficial, unfortunately. But you can again, kind of corroborating the initial lifestyle intervention study, and again, these foods again adhere to the Mediterranean diet. Substantially reduce the risk of chronic diseases. So again, taken as a whole, it's probably not exactly news to you, but taken as a whole, it shows how the importance of diet in maintaining good health, or at least reducing your risk of dementia, cardiovascular diseases, chronic diseases, and ultimately death. Now, obviously, hand in hand with diets is, especially when in terms of lifestyle interventions, is of course exercise. And generally speaking, the more, the better. And two studies here looked at exercise. The first one looked at the substituting sedentary time, so sitting down, watching TV and whatever, with exercise, or vice versa. And they looked at the phenotypic age, which basically is similar to epigenetic age, but involves taking 9 blood biomarkers and putting it into some calculations, and it gives you sort of your phenotypic age, whether or not you're aging faster or more slowly. And actually, a little heads up, In my rapamycin trial, I took this age test myself. Anyway, I won't go into the details too much, but again, no massive surprises that for people who substituted 30 minutes of sedentary time with exercise, that improved or that's slowed down their phenotypic age acceleration. Unfortunately, the wording here is quite sort of a bit suspect. In terms of the key points, you'll see what I mean. So 30 minutes a day spent on sedentary behavior was positively associated with pheno-age acceleration, which means, well, you aged more quickly. 30 minutes a day spent on leisure time, moderate to vigorous physical activity was adversely associated pheno-age acceleration. So that means you aged more slowly. And again, replacing the sedentary behaviors with moderate to vigorous physical activity slow down your age rate, and vice versa. They didn't sort of have specific figures for that, but again, nothing you probably didn't know already, but still, it's always nice to see it corroborated. Now, this second one was much more interesting, in my opinion. I'll look at the lifespan.io's synopsis of it. Now, this one is looking at walking and mortality, or how many steps a day people take. And of course, a lot of people are sort of aiming to try to get up to sort of 10,000 steps. That's sort of some this figure that is being bandied around. And generally speaking, the more steps per day, the better. And this study confirmed that as well. However, it was looking at how many, it was looking at a cutoff point of 8,000 steps a day. Now, previous studies have shown that, going from, say, 2,000 steps a day to around 7,000 or so, there's a very steep decline in mortality. But from around 7,000, it starts to level out until roughly when you get to around 10,000 steps, there's no real improvement if you go beyond that. But what this study was looking at is how many days per week you can achieve a certain amount of steps, in this case, 8,000 steps. And this is where it gets interesting, because first of all, the cutoff point on the study, as I say, was 8,000 steps. And looking at these two initial charts, this is for everyone. I think how many people were involved in this study? 8,000 people were involved in this study. And also, I should mention that the average American walks 4.8 thousand steps a day. But here you can see these two charts. First one is all-cause mortality. The second one is cardiovascular disease mortality. And you can see that at the bottom here is the number of days people walk more than 8,000 steps. The bars show the percentage of people who achieve that. And the line here is the mortality risk. And you can see that for all-cause mortality, it declines. It declines until it reaches roughly walking 8,000 steps for 5 days a week, and then gets slightly worse after that. And sort of similar with cardiovascular disease mortality, where there's a steep decline until you get to around 4 days a week, and then oddly enough, it starts to increase again. So this implies, and I mean, there's some other studies which show this, that there is more exercise is better up until a certain point, because I think our bodies need to be able to recover from the exercise, and if they don't get the chance to repair and recuperate, that actually can be detrimental to us. Now, even more interesting, when they not even more interesting, but when they subdivided the participants between those who were under the age of 65 and those who were over the age of 65. Firstly, for those under the age of 65, you can see that they had three categories here: either no days a week getting 8,000 steps, 1 or 2 days a week, or 3 to 7 days a week. And for those under 65, Actually, there was not really any difference, or hardly any difference, between just getting those 8,000 steps a couple days a week or doing it more than that. Now, for those over the age of 65, we can see obviously these bars are higher because people over 65 are more likely to die, unfortunately. But you can see here that for those over the age of 65, the bar is quite high for those who don't get up to 8,000 steps any day of the week. Quite substantial reduction if you can just manage it for 1 or 2 days a week. And there's a continued but not as great a reduction if you get beyond that. So, I mean, the take-home message here is that you can get quite a big positive effect by just, walking 8,000 steps a day, 2 days a week. So you don't need to worry. I mean, here, look at the numbers for those over 65. There was almost 20% reduction walking 1 or 2 days, and a 27% reduction if it was more than 2 days compared to the 0 days people. But again, the main sort of takeaway here is that if you're sort of stressed about, you don't have time to exercise, you can't get your steps in every day, just being able to do it once or a couple times, 3 or 4 times a week, can result in a quite substantial improvement in your mortality risk, especially your cardiovascular mortality risk. So as long as you get some exercise in, it's obviously better. And is again, sort of stress in itself is not very good. So better not to stress and, appreciate what you can do then, rather than worry about what you're not able to achieve. Moving on from sort of lifestyle interventions into sort of into a supplement study. Here was a study involving the supplementation of selenium and coenzyme Q10 in a population of Swedish individuals or Swedish elderly. How many people were involved? Not a huge, the numbers here, but oh yeah, only around 300 people or so. But this was they were basically given a combination. Well, either they were given or not, a combination of 200 micrograms of selenium and 200 milligrams of coenzyme Q10 for 4 years, and then their cardiovascular mortality, was followed up for another 10 years. And those on this combined supplement regime had roughly half the mortality of cardiovascular mortality of those who were not on it. But what this study sort of specifically looked at was the levels of SIRT1, which is a so-called sort of longevity gene, though it's still a little bit sort of disputed. And they looked at the SIRT1 levels in the blood, and what they found was that those who were taking this combination, these two supplements, had a quite considerable increase in their SIRT1 levels. So the blue line are those who are on placebo. So you can see it didn't really went slightly down over the course of the 4 years, 48 months, whereas those taking both supplements saw a substantial increase. So why does this matter? Well, as I just mentioned before, SIRT1 is considered a pro-longevity gene. More of it is generally considered better. And when looking at the people who actually ended up, unfortunately, dying, you can see that those who ended up dying, their levels of SIRT1 dropped. So obviously, whereas those who didn't die, it sort of remained stable or indeed rose. obviously, as I mentioned before, those in the placebo group had roughly double the mortality. I believe it was, I mean, again, relatively small size. Yeah, sort of like 52 out of the 160 in the placebo group died, whereas only 25 in the 160 of the active group died. But there've been sort of questions about how to raise sirtuin levels. So that's one reason why people take resveratrol, for example, or the NAD plus precursors like nicotinamide, riboside, and nicotinamide mononucleotide. And again, so this is a more indication that potentially raising levels could be beneficial. And if you've watched any of my previous videos or read any of the previous newsletters, you know how excited I get about combinations of treatments, because we're not going to cure aging by taking single treatments. It's going to be the combination of things which will prove beneficial, as this study shows. Now, the final study from the Roundup section is nothing to do about lifestyle, nothing to do about supplements, but involving gene therapy, and quite possibly might negate the need for exercise at all, because in this study, scientists gave the gene therapy to 18-month-old wild-type mice, and they injected something called neurotrophin 3, whatever that is, and they wanted to see whether or not it improved their muscles, basically, because one of the very sort of dangerous, not so much chronic disease, but dangerous conditions of older age is something called sarcopenia, which basically is the wasting away of muscles. So older people lose strength and are more likely to fall over, therefore, and just generally make day-to-day living more difficult. And exercise is a fairly good remedy for sarcopenia. However, people who are already elderly might not, might be bedridden, might not be able to exercise, maybe, might not be able to sort of start exercising because of their condition already. Obviously can't benefit from exercise, whereas a gene therapy could theoretically circumvent that. I'm taking a look at this study and what effect it had on mice. So, well, cutting to the chase is basically the 18-month-old mice, their muscles return to that of 10-month-old mice. So I guess sort of in terms of mouse to human year conversion, 18 months, I'm not 100% sure, but I think it's sort of late middle age or early old age, whereas 10-month-old is sort of early middle age. And here are the results. The dark bars are this is UT, the untreated mice. The gray bars are those mice which received the gene therapy. And obviously they tried various, they tested them in various ways. The first one was how far they could run in a given time. And you can see in each of these, the gray bars are substantially greater than the dark gray bars. So the light gray bars are substantially higher than the dark gray bars. So the axis on the left is how many meters they ran, and at the bottom is how many months after the gene therapy was injected. So 2 months, 4 months, and 6 months. And in all cases, it was substantially higher in the treated mice. Now, here is just looking at the treated mice, but looking at the sex differences between males and females, and it looks like the dark bars are the female mice. This gene therapy had a greater effect in female mice than in male mice, at least in terms of running distance. And here on the right is the untreated controls. Another test they did on these poor mice was a rotor rod test, where you've got a bar which basically spins and a mouse is trying to cling on for dear life. And well, they don't they don't get harmed if they fall down. But anyway, you can see here. So on the left, it's showing how many seconds they manage to stay on the rotor rod, and you can see once again that the treated mice can stay longer on it. And the next two charts or bar graphs are showing basically how the strength of the muscles, and so two types, twitch and tetanic, two different types of muscle force, how much force the muscles can generate. Once again, the treated mice have a can generate substantially more force than the untreated mice. And what else? So yeah, just some pictures of the mouse, and again, just cross sections of the muscles, and darker staining is better basically, and the treated mice have darker staining. But should just also mention that not only did their muscles increase and their physical performance increase, but there was also, the researchers say that there was improvements in their fur and hair, so they kept more hair, and I think they didn't have as much psoriasis. And also there was less, the untreated mice had greater curvature of the spine, which is also a age-related condition. So one good thing with say with gene therapy is that it's, which would involve a single injection, then you're sort of good to go. Okay, after that slight technical glitch, we've come to the end of the roundup section for March, but there are a few more studies in the supplemental section I just wanted to point out to you without going into too much detail. Firstly, a study about curcumin, and specifically its bioavailability, because curcumin, which is so the active ingredient in turmeric, which is the sort of the yellow curry spice, has very, very poor bioavailability. I take it as part of a sort of a drink I do. I just put turmeric powder in and add pepper to it, because pepperine, the active ingredient in black pepper, can slightly enhance its bioavailability. However, various companies have produced numerous different formulations which supposedly have enhanced bioavailability. And this review sort of takes a look at all of the various different forms. And again, I won't go through this, but looking just at this chart here, you can sort of see that talking about first generation formulations, second generation, third generations, and as the generations have gone up, the bioavailability has improved. And actually, after having read this, I'm now seriously considering taking one of the third generation ones, though they're a lot more expensive than pure just simply using turmeric powder. But it probably could well be beneficial. But have a read of the entire study to look at the differences, or study this review of all the different formulations. And why should you care about its bioavailability? Well, there are a number of other studies here under curcumin, and such as that it can help with weight loss, if you have a heart attack, or even chronic obstructive pulmonary disease, COPD, and even with this other so the three I just mentioned are also the reviews, umbrella reviews, systematic reviews of numerous studies. And sort of the one here, which looked at curcumin for in terms of effect it has on colds and cold symptoms, and it's basically these Japanese participants, it reduced the length of their cold symptoms. But in most of these studies, they mention the fact that it is the higher bioavailability forms which have which have a better effect. So as I say, I'm now seriously, I probably I pretty much decided, actually, I just need to actually go and order some for both myself and my parents of some high bioavailability curcumin, because it does seem to be a quite beneficial supplement. Carrying on to the other available supplement sections, where there are a number of interesting reviews of supplements. So first one, again, I'm just going to point these out. You can check them out yourselves. But there's one here for alpha-ketoglutarate, which is a relatively new supplement in the longevity field, and seems to have quite a number of beneficial effects. Another one is ashwagandha, which is something I don't really know too much about. But again, there's a good review of it here. And also glycine, which is an amino acid, and I take glycine in, well, it's one of the major constituents of collagen. So actually, when I have my turmeric drink, I also have collagen powder in there, and mainly to up my intake of glycine, which has numerous beneficial effects when it comes to aging. And just want to point out a couple more studies. Talking about dementia risk earlier, here's that people who take at least some vitamin D seem to have a 40% lower rate of dementia. And also, continuing with dementia, looks people who have higher intake of magnesium. So this was primarily looking at dietary magnesium. Again, seem to have lower risk of dementia, and in this case, also higher or greater brain volume, which I guess is a good thing to have. I want to finish off before moving on to my own results on just to mention a couple other, where are they? Here we go. Just in the opinions editorials theory section, there's a really interesting paper on looking at aging as a software design flaw, which is sort of similar actually to the information theory of aging, which David Sinclair has sort of come up with. And Pedro de Magalhães, who's a Portuguese researcher up in Liverpool, in the UK. Anyway, quite readable and thought-provoking theory on aging, which is worth your time as well. And finally, another sort of review I'm just going to point out about basically everything you wanted to, or maybe didn't want to know about cellular rejuvenation. So that's partial epigenetic reprogramming, things like that. This review in Nature is quite comprehensive and got lots of, even if you just take a look at it, to take a look at the figures and stuff. It's quite long, but if you have any desire to know more about cellular rejuvenation, which is sort of the hot topic in aging research, that's where a huge amount of money sort of flowed in. If you've heard about Altus and various sort of aging startups, and lots of companies, lots of people are looking into this, and maybe in 10-15 years this could be could be available for human use, and could be one of the main means we could rejuvenate ourselves. So if you want to learn more about that, you can read this quite comprehensive review. So okay, now I want to finish off, I want to go through some of my own results. So if you're unaware, between September and December last year, I start again. I basically got hold of a 3-month supply of rapamycin, which taking a step back actually. So rapamycin is an mTOR inhibitor. And mTOR is one of the sort of the main signaling pathways in aging, and it's sort of one of these sort of nodes that affects multiple processes in our bodies. And when mTOR gets inhibited, lifespan generally increases. And rapamycin inhibits mTOR, and it was the first drug proven to increase the lifespan of a mammal back in 2009. In fact, in every species, every strain of mouse it has been tried in, it has increased their lifespan and also importantly, sort of improved their health span. So there's an idea that rapamycin could theoretically reduce your chance of getting cancer, reduce your chance of getting Alzheimer's, reduce your chance of getting cardiovascular disease. It is literally, it doesn't maybe cure all of those different diseases, but it certainly has a beneficial impact on most of them, especially in animal models. Now, I say it's been very successful in animals. Now the question is, does it work in humans? And increasing number of biohackers have been testing it out on themselves, and there's a lot of anecdotal evidence that it is beneficial. And there's human trials now taking place to see whether or not it actually is beneficial. But I decided to sort of jump the gun and get hold of some myself and try it out on myself, because as far as all the reading I have done, it is relatively safe to take, and the side effects, if they occur, are manageable. Now, in my own case, I took it for 3 months, and the dosage I took was 5 milligrams per week, once a week. And well, to cut to the chase, I didn't notice anything. I mean, I was relatively healthy to start with, so I wasn't expecting to notice, but I was sort of watching out for any potential side effects. The most common of which is to develop some sort of transient mouth ulcers, mouth sores, but I did not get any of those. However, I took various. I wanted to. Because I wasn't expecting to feel anything from it, I wanted to see if it had any effect on my sort of biological age by taking a number of before and after tests. Now, the three before and after tests I did was doing my pheno age test, which involves getting blood work done before and afterwards, and basically taking 9 biomarkers, or nine different things such as albumin, creatinine, glucose, macrotide, as I say, 9 different sort of parameters, and putting them into a sort of a spreadsheet calculation, and it's out sort of pops your pheno age. Secondly, I got before and after age tests from GlycanAge, and which GlycanAge basically measures glycans, which are proteins on the surface of cells, and they sort of line up with your age according to a few different studies. And also, I got an epigenetic age test from AgeRate, which is a Canadian startup currently in beta testing. Now, I should say for those two, for both GlycanAge and AgeRate, I got those tests for free. So sort of lucked out. I sort of lucked out there. Anyway, let's take a look at my actual results. And well, they were quite a mixed bag, because my pheno age went from 41.1 years to 35.7, which I was, well, you can understand, quite ecstatic about. And actually, I should mention that I was 46 and a half when I started my trial, and 3 months later I was 46 and 3/4 years old. So I already, according at least to the pheno age, I was already roughly sort of 5 years younger than my chronological age, and that further improved to 35.7 now. So I was really quite happy. And when I had my annual checkup in December and showed this to my doctor, she was quite impressed, or she was intrigued, and sort of could point out which of the 9 biomarkers related to which organs or which organ systems in the body. And as I say, everything sort of seemed to improve, at least from this test. Moving on to the GlycanAge test. Now, GlycanAge offers a free consultation, which I have not had the chance to have yet, and I will eventually get around to doing it, because to be honest, the results came back slightly unbelievable. So my before test came back saying that my GlycanAge was 22. In other words, sort of 24 years younger than my actual age, which I found it quite difficult to believe. And 3 months later, when I retook the test, it had increased to 23 years. So I theoretically got a bit older, but still 23 and a half years younger than my 23 years younger than my actual age. Now, the last result I got took a while to sort of come back, was from age rate. And now, but my before test there was 45 years old, so I was a little bit disappointed at that at the time. You know, it was only a year younger epigenetically. But then my after one, my age went up to 48.1, which was a little bit of a shock. Yeah, I don't quite know what to make of that. I'm actually going to be scheduling a call with the CEO of AgeRate and chat to a bit more what these tests might mean. So yeah, there you have it. A mixed bag of results. I was hoping that all 3 of these sort of age tests would move in the same directions. You could say, oh, you could definitely say that rapamycin was working, but they didn't. And my own opinion is that we're still in the early days of biological age sort of testing. There are lots of new tests on the market, but you know, buyer caveat emptor, buyer beware. They still need to be, I think, sort of properly, fully validated and tested in large cohorts of people. I mean, I tried during my 3-month trial to sort of keep everything the same. The only difference being that I added rapamycin to my regime. But my biggest takeaway was just realizing how difficult it is to conduct clinical trials, especially lengthier ones like that last 3 months or so, where you know life comes at you in different ways. And although I was trying to keep everything the same, could I keep everything the same for 3 months? Hell no. I mean, I went on holiday during that time, so I sort of relaxed a bit. Also, my mother was hospitalized for COVID during that time, which was quite a stressful event. I also had a house move during that time, which was not as stressful as my mom getting COVID, but still not ideal. So yeah, I developed a much greater appreciation for people who have to run clinical trials and why it is so necessary to have a large cohort of people taking part, because that's the only way you can sort of get statistical relevance, statistical significance, because there's just so much variation on the individual level. Now, just to sort of wrap all this up, I still am a believer in rapamycin. I have read too many studies showing its benefit, especially in the preclinical setting, and because it impacts one of the sort of the key aging drivers, which are present in all life forms. And as I say, it's beneficial. It's been proven beneficial in all of the life forms it's been tested in. I really do believe that that rapamycin has a useful future in the longevity field, and it is something that I plan to take again in the future once I get a more stable supply, as I think three months is not enough to sort of confer a longevity benefit, and maybe taking it for long, maybe taking an entire year or more maybe I will see a greater change in all 3 of these tests, or whichever tests I do in the future. Anyway, we've reached the end, and so all there's left for me to say is thank you very much for watching. And please, obviously, I guess I should, since every YouTube video says it, please subscribe to the CLA's channel and hit the like button. And look forward to you joining us, or joining me, next month for the next edition of the Longevity Review. Take care and stay healthy. Bye.